The film you are about to see tells a story from a bygone era. That statement may seem strange, since the film was made only a decade ago, and the development of the great river of the West, the Columbia, is still going on. As you watch the film, you may want to bear in mind that environmental awareness has grown to full realization in less time than the film has aged. It would be an exaggeration, however, to say that the developers have spoiled its environment. To the contrary, in many instances, they have preserved and enhanced it. But we'll let you judge that for yourselves.
To everything there is a season, and a time to every purpose under the heaven. A time to break down, and a time to build up. For the Columbia River, the time to break down, to sweep aside everything in its wild rush to the sea, lasted 70 million years. Think of it. This greatest of all the rivers that water the Pacific raged across the land unchecked for 700,000 centuries. The time to break down, and yet a time to build up. For in the very process of running wild, the Columbia was carving its channel, making itself ready for man to put it fully to work. That time came only a second ago on the clock that ticks the age of the earth, or as man reckons time, little more than a quarter century ago. The starting gun for full development of the river sounded in the 1930s. An army of men and machinery went to work like there was no tomorrow. Round the clock, they chipped away at the age-old canyon walls, reshaping the face of the ancient land, making way for the future. And in 10 short years, 3 dams went up across the Columbia. Rock Island, built with private capital for power alone, was first. Bonneville Dam, built by the Army Corps of Engineers for power and navigation, was next. And then, the granddaddy of all American dams, Grand Coulee, built by the Bureau of Reclamation for power, irrigation, and flood control. Here was the dam that finally fixed the bit in the Columbia's jaw, Grand Coulee, to that time the greatest man-made structure anywhere. Here was the dam they said couldn't be built. Here was the dam that culminated 20 years of struggle by never-say-die visionaries, men often considered wild dreamers in their day. A dam so big it could embed 4 United States Capitol buildings. A dam 1/10 of a mile high, 4/5 of a mile across. A barrier so big it formed a lake 150 miles long behind it, providing massive control of the river and making it the keystone structure of the system. Yes, truly a bit in the Columbia's jaw. After Grand Coulee, the word along the river was go. Now the time was right for the grand purpose, transforming the Columbia and its tributaries into a working river system, working for the people, to provide benefits for every family in every corner of the region. Building up the mighty Columbia, one of the Earth's truly great drainage basins, meant many things to many people. The sheer brute force of its surge to the sea could be harnessed for power, for industry, and jobs. Its tremendous water capacity could be used to irrigate croplands, to produce food for America's multiplying millions. Its rough and unruly road to the sea could be smoothed like a rippling lake for inland navigation. Its wild and unpredictable ways could be bridled to control floods and save lives and millions of dollars of property. Here was challenge, raw and exciting. Here was opportunity of the first magnitude. Let's look at this Columbia River Basin country. It's a vast region stretching from the Continental Divide in western Montana to the Pacific Ocean, and from southern Oregon deep into British Columbia across the Canadian border. It is a land of rugged mountains, fertile valleys, and desert reaches, interlaced by the Columbia and its major tributaries, plus hundreds of lesser streams. The Columbia's full potential for greatness as a source of electric power and irrigation was there from the beginning. Power because the river dropped 2,500 feet from its source in Canada to the sea, with nearly 1,300 feet of that drop on the American side of the border. Irrigation because high mountains cut off rainfall from huge areas in the interior of the basin. A closer look at the map reveals a paradox of the great Pacific Northwest. Right in the midst of this great concentration of rivers are vast stretches of wasteland, almost as bone dry as Sahara itself. This is a picture of the Northwest that has to be seen to be believed. An arid wasteland that received less than 10 inches of rain a year broke the back and heart of many a pioneer farmer who tried to coax a living off the soil in the basin areas just after the turn of the century. However, the mountains which caused this paradox in the first place also provide an important link in making water available from the river for man to turn wasteland into good land. It works this way. Moisture lifted out of the Pacific by the sun is transported across the land in heavy cloud banks. Colliding with mountaintops, the clouds are wrung dry of moisture, which drops in the form of rain in summer and heavy snows in the winter. Snows that measure 20 feet deep and more. The melting snows create the many brooks, streams, and rivers that feed the Columbia. The waters flow through gullies, gulches, gorges, twisting across the crust of the earth to lower ground, heading for the source of all water, the ocean. The cycle is repeated again and again. Out of the sea and over the mountains, then through the land, back to the ocean. The closest thing to perpetual motion known to man. Man went to work on this inexhaustible gift of nature. Grand Coulee and Bonneville dams were the two ends of the main stem Columbia system south of the border. And after Grand Coulee, all things were possible downstream. In rapid succession came McNary, Chief Joseph, the Dalles, Priest Rapids, Rocky Reach, and one of them, all completed since 1950. John Day is under construction. The federal dams on the main stem are multi-purpose dams, built for power, irrigation, flood control, navigation, and recreation. All dams downstream from Chief Joseph, federal and non-federal, have extensive fish facilities. Altogether, there are now more than 140 dams on the Columbia and its tributaries, impounding at capacity 30 million acre-feet of water for river control and man's use. Enough water to cover 30 million acres to a depth of 1 foot. Hungry Horse Dam, the first major upstream storage dam in the system, went to work in 1953. Built by the Bureau of Reclamation on the South Fork of the Flathead River, high in the western slope of the Montana Rockies, Hungry Horse is a prime example of how the river system works. As snows in the mountains melt in spring and early summer, upstream dams like Hungry Horse contain the flood. Later in fall and winter, when streams run low and power demands are at a peak, upstream storage is released to fill the gap. Water flows through the generators at Hungry Horse, producing 200,000 kilowatts of power at site, and moves on through all the other generating plants downstream, working 16 different times before it reaches the Pacific Ocean, increasing downstream energy production by about 1 million kilowatts. Hungry Horse Reservoir is low in the spring before snows melt in the upper Rockies, and then the cycle is repeated. The reservoir is full again by midsummer. You can't store electric energy, but you can store a full reservoir of water. When flood threats are imminent at the dam site, the water level can be lowered well in advance, either by discharging water through these pipes built into the dam for flood control and normal reservoir regulation, or through this glory hole, which drains water directly from the surface of the reservoir. The glory hole also serves as an overflow pipe. Both devices make ready the necessary space to store incoming floodwaters. But to men whose lives are dedicated to full utilization of our water resources, spilling water is not a happy sight. It's lost water, energy gone to waste for lack of storage. And at Grand Coulee, the water cascading over this spectacular spillway means more waste, again for lack of storage. To experienced eyes on the river, the water that looks good is the spent water, swirling out from the great turbines beneath the powerhouse. This is water that has been used. Despite the wasted water over the spillway, this giant dam still is the greatest power producer in the Columbia River system, and one of the greatest on Earth. This powerhouse and another like it on the other side of the dam produce 2 million kilowatts of power. River power of the Pacific Northwest, harnessed by immense and intricate machines, produced by men working in Youngstown, Pittsburgh, Schenectady, spreading the indirect benefits of Northwest power development clear across America. 30 million men pounding sledgehammers couldn't do the work of one Grand Coulee Dam. Federal plants are tied together in the Pacific Northwest power grid and interconnected with more than 100 different electric utilities from the Rocky Mountains to the Pacific Ocean. Power is dispatched from the Bonneville Power Administration Control Center in Portland. As stream flow is controlled by an integrated system for balanced use of water, so the Northwest Power Pool is a balancing reservoir that ensures maximum use of the electrical energy produced. The transmission grid makes available to the whole region energy produced by all major power sources in the region, wheeling electricity where it's needed, when it's needed. The Bonneville Power Administration grid assures the widest possible distribution of low-cost federal power. It serves as the transmission backbone of the Northwest Power Pool. It is used to wheel non-federal power, thus eliminating the need for duplicating lines. It stands as a guarantee against anyone monopolizing the benefits of this great public resource, the Columbia River. Moreover, Bonneville Power Administration revenues from the sale of low-cost federal power repay the Treasury with interest for Power's full share of the cost of Northwest federal dams. Power revenues also help substantially in paying for irrigation projects. Bonneville Power Administration's 8,000 miles of transmission lines carry power to municipalities, public utility districts, cooperatives, private power companies, and to industry. Low-cost federal power that offsets the Northwest's twin disadvantages of distance from market and high shipping costs. When Anaconda Aluminum followed Hungry Horsepower to Montana, it immediately became the biggest taxpayer in Flathead County. Anaconda is only one of 8 major aluminum plants which have located in Oregon, Washington, and Montana. At other electroprocess plants scattered throughout the Northwest, power represents up to 25% of their total cost of doing business. And besides such inevitable consumers of electricity, nearly all manufacturing industries in the Pacific Northwest are more dependent on electric power than those in other parts of the nation. The forest products industry, traditional backbone of the Pacific Northwest economy, utilizes power to get more and better products from every tree. There's phosphate rock in Montana and Idaho, and a lot of it. With power, it can be and is processed into fertilizer and many consumer products. Of all the rivers in America, only the Mississippi carries more water. During the course of the whole year, the Columbia funnels enough water into the sea to fill Lake Erie 10 times over. By far, the largest use of this water, as water, is for irrigation. Grand Coulee, keystone of power production on the river system, figures large in irrigation also. Through these gargantuan pump lines, water is lifted with Grand Coulee power 280 feet out of Franklin D. Roosevelt Lake into this mile-long concrete-lined canal that at full operating capacity feeds 30,000 tons of water a minute into Banks Lake, site of the old dry coulee, which was carved out by the Columbia during the Ice Age. Water from Banks Lake is now irrigating about 500,000 acres of once arid land in the Columbia Basin project. Ultimately, twice as much land, 1 million acres, will be irrigated in this one project. Lands once considered desert, barely able to support sagebrush and cheatgrass, are now producing 7.5 tons of alfalfa to the acre. The irrigated lands of the river also produce highly specialized crops in great variety, food for a growing population. These specialized crops do not contribute to the farm surplus. Grand Coulee Irrigation has already provided an opportunity for thousands of Americans to make it on their own. In a single decade, millions of dollars were spent on this one project for machinery, buildings, and improvements. A new and expanding market was created for products from all over America. Dying towns have come to vigorous new life, and new cities have sprung up where there was only desolation before. Development of the Yakima Valley more than half a century ago set the pattern for utilizing government-built irrigation facilities elsewhere in the Columbia River Basin. Its nearly 500,000 irrigated acres yield an abundance of world-famous Washington apples, as well as other fruits and vegetables. The early dams and irrigation works, which were responsible for transformation of virtual desert into productive land, were long since paid for in full by the water users themselves. Down toward the other end of the vast Columbia Plateau, in the Snake River Basin, more than 3 million acres are already irrigated. Here, too, large-scale development began before 1910, when the Bureau of Reclamation built the Minidoka Dam, generator of the first federal power in the Northwest. Minidoka was built on nothing but wasteland as far as the eye could see. Not a town in sight. Now there are 8. Dams like American Falls, situated a short way upstream from Minidoka Dam on the Snake, and Owyhee Dam, located on the Owyhee River in southeastern Oregon, are only 2 of the more than 50 reservoirs that are storing the waters of the Snake and its tributaries in Idaho and eastern Oregon. As irrigation develops in the basin and more food crops are grown, more and more processing plants dot the landscape from one end of the once desolate Columbia Plateau to the other. More investments, more jobs, more wealth, as more and more of the river system goes to work. The transportation industry shares the benefits from an expanding Northwest economy for which the river is so much responsible. And the river itself contributes enormously to this big freight hauling job. Today, the old water highway along which Lewis and Clark blazed the first western trail for the fur traders and settlers who were to follow, now carries ever-increasing loads of farm products down to Portland, Vancouver, and world markets. The traditional pattern of agricultural products downriver and petroleum products up is expanding to a longer list of commodities. Today, tugboats can push their cargoes all the way from Portland, itself a deep water port, to Pasco, Kennewick, Washington, 325 river miles inland from the Pacific. Through most of the way, tug and barge move from one slack water pool to another. Water stilled by the same Corps of Engineers dams which provide the locks to lift this riverborne traffic. However, there's still a stretch of open water between McNary Dam and the Dalles in which it takes 2,000 horsepower to push a 1,000-ton barge. With the completion of John Day Dam between McNary and the Dalles, the same tug will handle 9 times the payload because the slack water pathway will extend from the Pacific to Pasco without interruption. And Ice Harbor Dam is the first of 4 Corps of Engineers dams in building the same kind of path up the Snake River to Idaho. The people whose working lives are enriched by the river turn to the same river for play and relaxation. The waters stored in reservoirs behind the dams provide excellent playgrounds. the United States, tourists are drawn to the area to view Grand Coulee, Hungry Horse, and other dams of the system, and in the process, supporting a recreation and tourist trade that is now one of the largest industries in the Pacific Northwest. Protecting the fisheries resource is another important part of river development. For example, Rocky Reach Dam, a project of the Chelan County Public Utility District, has a fish ladder nearly a quarter of a mile long to help salmon and other game fish make their way upstream to their traditional spawning grounds, and an intriguing viewing room where the fish can actually be seen during their passage up the ladder and their progress charted. Preserving sport and commercial fishing is a continuing concern of the Fish and Wildlife Service. Indeed, the past quarter century plus has been a time to build up in the Columbia River Basin. Much has been accomplished, but much still remains to be done. Population growth in the Pacific Northwest means that in the next 10 years, 1 million jobs must be created. The region must do its part in helping the nation to feed 3 million new mouths every year. Where are these jobs and this food to come from? The river system has many of the answers. Every time you put a generator on the line, you put a payroll on the line. Power from the system already sustains industrial growth for more than 5.5 million people in the region. It can also provide jobs for today's children, tomorrow, opportunity for them to work and live and build their homes in the land where they grew up. On a national scale, energy is the lifeblood of our economy and vital to enabling us to compete in world markets and to meet our world responsibilities. Through application of pioneering programs developed on the Columbia, our nation is moving ahead to interregional power grids, development of extra high voltage transmission, and maximum efficient use of our power resources. Every time you reclaim 1,000 acres through irrigation, you provide a living for more than 200 people on the farms and in the towns that serve the farm population. And each forward step in industry, in agriculture, and in riverborne commerce helps create the wealth that pays the taxes and supports the schools and other public services of a healthy community. The cities grow and the kids grow up, and the future belongs to them. But what is done now and in the years that are racing toward us will shape that future for generations. And what can be done? Through irrigation, more than 3 million acres of new land can be developed in the next 50 years. Only 1/3 of the river system's power capacity is being used. Much of the other 2/3 can be put to work. At Chief Joseph Dam, for instance, when more upstream storage is developed, space is ready and waiting for 11 huge pipes, penstocks, to carry water to 11 new generators. At Grand Coulee, the capacity of America's greatest dam could be increased 50% by adding a 3rd powerhouse in this vacant area.
At its close, the 1963 film made a statement about flood control. It said the floods of 1948 and 1961 are grim reminders that this great river system must be further controlled for all time to come. Now, fortunately, it is controlled. The 1972 spring runoff was far greater than that which caused the 1948 flood. The river was held in check by new storage reservoirs behind the new dams, Dvorak, Duncan, Keenleyside, Libby. A major flood failed to materialize. Approximately 7 million acres of land are now under irrigation in the Columbia Basin, and the annual crop value has risen to $1.5 billion. Under the provision of the Columbia River Treaty between the United States and Canada, proclaimed in 1964, 2 dams have been completed in Canada. Duncan Dam at the foot of Duncan Lake in the Kootenai drainage was completed in 1967, and Keenleyside Dam at the foot of the Arrow Lake on the Columbia River finished in 1968. These dams, together with Libby Dam, the U.S. treaty project on the Kootenai River in western Montana, and Dvorak Dam on the North Fork of the Clearwater River in Idaho, helped to prevent a major flood in 1972. In 1973, Micah, the third of the Columbia River treaty dams, began storing water. Completion of these storage dams has increased the capacity of the storage projects in the Columbia Basin to 40 million acre-feet for flood control and power. That third powerhouse at Cooley Dam, mentioned in the original film, is now well along. But instead of increasing the capacity by 50%, the first 6 generating units of its potential development will more than double Grand Coulee's capacity by using the largest hydroelectric generators ever built in the Western world. Ultimately, this 12-unit power structure will increase capacity to 9,700,000 kilowatts, 4 times the original development, making Grand Coulee the world's largest hydroelectric dam. At the Dalles Dam on the lower Columbia, 8 generators have been added. John Day Dam has been turning out power since 1968 and is currently rated at over 2 million kilowatts. John Day's lock, the highest lift on the river at 113 feet, now eases the course of barge tows operating between the lower river ports and the interior of the state of Washington. Ice Harbor Dam was the first step up the Snake River on the way to Lewiston, Idaho, 400 miles from the Pacific Ocean. In addition, 2 more steps have been completed. Lower Monumental Dam with its present power capacity of 405,000 kilowatts and spaces for 3 more generators of equal capacity. And Little Goose Dam with an equal amount of power on the line now and additional potential. Well past the halfway mark on its construction schedule is Lower Granite Dam. It is the last stair step in the Columbia and Snake Rivers navigation system from the Pacific Ocean to the heart of the Inland Empire. The high-voltage transmission grid of the Bonneville Power Administration now comprises some 12,000 circuit miles and more than 320 substations. 3 intertie lines, 2 alternating current at 500,000 volts and the other direct current at 800,000 volts, link the Pacific Northwest and Pacific Southwest for an interchange of power between the 2 regions. Yes, the great river has been harnessed to serve man and to enhance his environment. Our standard of living in the Northwest depends largely upon the development achieved over the past 4 decades. Were it not for these developments of Columbia River waters, a constantly renewable source of energy, it is doubtful that the Pacific Northwest would be the dynamic region it is today, and most important, will be for generations yet to come.